One, two, three.
What's up, team? Today we're going to talk about the quadratic formula. Learning target: I can solve a quadratic equation using the quadratic formula. So this is the third of three ways that we're going to discuss solving quadratics. The first one was graphing, second one was factoring, this is the third one. I'd argue it's the most powerful of the three methods to solve quadratics because it'll always work. For example, if you're graphing a quadratic, sometimes you can't tell exactly where it crosses the x-axis if you're doing it by hand. And then for factoring, not all of these things can be factored. The quadratic formula will always work, so it's super powerful, super versatile. The downside to that is it's a little bit tedious, and if you're looking at the equation right here, the formula itself, it's a little intimidating looking, but I'm going to do my best to make it feel as comfortable as possible as we do this one example. So we got a step-by-step directions. I'm going to kind of walk through them, and then we'll do an example together. First of all, here's the formula. Again, it's gross. I know it's intimidating, but I'm going to do my best to make it as easy as possible. So we have x equals negative b plus or minus. That's new. That's a little weird. We'll talk about it. Plus or minus the square root of b squared minus 4 times a times c all over 2a. So the first step, we're going to solve for 0. We've done that for all of these quadratics so far. Nothing new. And then things turn on us a little bit. Step 2, we're going to plug our a, b, and c values into the formula. So we know every quadratic has an a value, a b value, and a c value. They're all real numbers. And we're just going to plug all the a stuff wherever we see a's, plug in the b's wherever we see b's, and plug in the c's where we see c's. And then we're going to simplify, because it's going to look real gross at first, and then we'll simplify little by little, and then it'll get pretty concise. And then step 4, we're going to split the two equations and evaluate. That's where this plus or minus thing comes in. So I'll explain that when we get there. It's really much simpler than it sounds and looks, that last step there. Okay, here's our example. It says solve for x, and we have x squared plus 5x equals 24. So step 1 over here, it says solve for 0. So I'm going to send everything to the left side. And the way I'm going to do that is I'll subtract 24 from the right, subtract 24 from the left, and that'll give us x squared plus 5x minus 24, and we'll set that equal to 0. Step 1, check. Step 2, plug the a, b, and c values into the formula. So let's first identify our a value, b value, and c values. Our a, that's what's in front of the x squared. So our a is 1, our b, that's 5 from right here, and oops, don't need an equal sign there. And then our c, that's negative 24, our constant. Okay, now we're going to plug them into the formula. I'm not going to rewrite the formula, it's over here, but I am going to rewrite it, but with our values plugged into it. And I'm going to shift over to this part of the board here. So we have x equals, and let's see, I'll do, I'll grab, no, you can't see the colors in the video anyway. Okay, so it's x equals negative b. Our b value is 5, so I'm going to put negative 5 plus or minus, I'll open up my radical. Now it says b squared. Our b value is 5, so I'm going to put 5 squared. So far, all I've done is I replaced this b with 5 and this b with 5, but I kept my negative and I kept that square sign. That stuff is still present. Okay, minus 4ac. So that's 4 times our a value. In this problem, it happens to be 1. And then c is negative 24. Sweet. Okay, cool. Now the whole thing is being divided by 2 times a. In our case, that's 2 times 1. That's step 2. Plug them into the formula. Check. Step 3, simplify. This one's going to not take a ton of time, but we're just going to do it piece by piece. We're going to break it up, because even this looks intimidating. There's a lot going on. So x equals, well, negative 5. I don't know how to simplify that yet. Plus or minus, we're still going to worry about that later. Let's look underneath the radical. 5 squared. I know what that one is. That one's 25. And then minus 4 times a times c. So 4 times 1, that's 4. And then 4 times negative 24. That's 80, 96. If you need a calculator for that, that's just fine. No worries. And in the bottom, 2 times 1 is just 2. Okay, still a little gross, but it's getting easier. So negative 5 plus or minus, so kind of running into the other line here. Plus or minus, now 25 minus a negative 20, or 96, that turns into a plus. So it's going to be 121. Looks like I got a little aggressive with my radical sign. Didn't need that much. All over 2. Ooh, now it's starting to look quite a bit simpler. Let's keep it rolling. Negative 5 plus or minus. Square root of 121. You can use a calculator for that. I happen to know that it's 11, so that's nice. There we go. This looks a whole lot easier to work with than what we started with. We're left with negative 5 plus or minus 11, and whatever that is, we divide it by 2. Cool. Step 3, check. Step 4, this is where it gets a little bit funky. We're going to deal with this plus or minus thing. So split into 2 equations and evaluate. So the first one, we're going to do the pluses. So we're going to take our most simplified version, negative 5, and now instead of plus or minus, we're just going to do the addition component. And over here, we'll do the minus, the subtraction. So negative 5 minus 11 over 2. So both of these came from the same place. This says negative 5 plus or minus 11 on top. So we did the plus version here, the minus version here, and we're going to end up with 2 solutions. That shouldn't be a surprise because when we solved all these quadratics, either by graphing or factoring, we generally saw 2 solutions. The same thing is going to happen here. So this is super simple to simplify. Negative 5 plus 11, that's 6 over 2, which is 3. So x equals 3 is one of our 2 solutions. And then over here, negative 5 minus 11, let's see, negative 5 minus 11, that's negative 16, and I still have a 2 on the bottom. Negative 16 divided by 2 is negative 8. So our other solution is x equals negative 8. There we go. So our 2 solutions for this original equation we were given, x equals 3 and x equals negative 8. These are the 2 different numbers you could plug in for x to make the equation true. If you were to graph this, you would find that it has x-intercepts when x equals 3 and when x equals negative 8. This one, turns out you could have factored this from the get-go. That was a little sneaky of me. But we definitely could have factored this. 2 numbers that multiply to negative 24 but add up to 5. Wouldn't we say that that's x, let's see, x plus, oh geez, what is it, x plus 3, no, x plus 8, sorry, x minus 3, there it is, multiplies to negative 24, adds up to 5, yeah, that all checks out. And we learned when we were solving by factoring, well, what makes this equal 0 when x is negative 8, boom, and what makes this stuff equal 0 when x equals 3, boom. So this one, we definitely could have done by factoring, but I wanted to practice solving by using the formula. More often than not, you're not going to be given one that can be factored. You'll see in the next video that I'm about to do that these can get real gross and you'll need a calculator and there's decimals and all this type of stuff when you're not given a nice, clean, factorable quadratic. Okay, let's dive into some practice problems. Let me know if you have questions. You got this.